Welcome, everyone. As Belle mentioned, I'm the founder of a company called Blue Connector, which is my consulting and training company. But I'm going to start with a question because we're all involved in information. We're all information workers. But have you ever been told or asked who are our biggest customers? What are our best-selling products? We're more searching, where is that report, or simply that's not the information I'm looking for. So this is what this session is about, is why we bother with data pipelines, is so that we can deliver data. You need to make decisions about it using data to make better business decisions, sell more products, serve customers better, and manage their business better. So a little bit about me. As Belle mentions, I do consulting and training in digital technologies. I have had a varied career across countries in Australia, about 8 years in the US, and the last 10 years here in Singapore. And I performed activities across a range of roles. So, and industries. So in addition to Blue Connector, I'm also an active community member. I'm the organizer of the Platform Engineers Singapore Meetup Group, the API Days Singapore Conference, which happens once a year. And the most recent one was in April. I'm also an instructor on the National University of Singapore's FinTechSG program, which is designed to prepare mid-career professionals for a career in FinTech. So for today's topic, is the real question is when you're trying to decide about creating a data pipeline, what are you going to do with the data? So there are three main categories of purpose for the data that's delivered through a data pipeline. Managers, analysts, actually any information worker needs to be able to work with data and interact with it through look at a dashboard so that they can see what is happening with the company or their corner of it, in order to improve on it, take any corrective actions, or take opportunities when you can see something is selling well or operating well. You want to double down on what's working. Reports are important. They're in different format because dashboards and visualizations are often quite interactive because we want to be able to drill down on particular information, but highlight the key metrics so that we don't get confused by the clutter. Whereas reports often need to be quite detailed, and sometimes they have a regulatory requirement or a corporate governance requirement to deliver on. The real value of data is when we can mine that information for insights, and which we can also share with customers. So we've all been exposed to recommendation engines, search engines, and sometimes we've had good experiences with search on a site, and sometimes it's been a little harder. The more we can do to optimize the information that algorithm that creates that, the machine learning algorithm, then the better the experience that the customer is going to have, and the better business we're going to operate. So these are all considerations for what we need to do in creating and delivering the data that people can use. Where's that next slide? Okay. So the key questions, though, that we need to ask in order to achieve all of those things is what data is needed to support the business decisions. and where is that data now? It may need to be combined from a variety of different sources, and how that gets linked together is a problem that we need to solve for other people. What form are they going to need the data in? Because there's different purposes, the dashboards, the reports, and the machine learning algorithms need information in a particular format. How much data there is will influence how we decide on the infrastructure that we're going to build, the types of tools that we're going to use, and how we're going to manage that. And then one of the really big questions is, how fast is the data needed? Now, if you ask someone how fast they need the data, they'll say, actually, I need it yesterday, but today will do. But all of the speed has a cost, and we find that when we construct data pipelines, we have to be careful about overbuilding and building just enough to meet the current needs with some flexibility for the future. So this is what's driving the configuration of the modern data infrastructure. The modern data infrastructure consists of several different things. So we have a lot of data is available now to be stored as in data warehouses and data lakes. I mentioned that it may come from different sources. So we may have different business applications, we may have websites, we may have third-party data providers. We need to be able to ingest that data into our pipeline. We may need to model the data or prepare data for modeling. And due to all that complexity, we may decide to use a workflow orchestration platform. So here are some of the pieces that we have. A data warehouse is essentially a big database, but in that it has lots of structured data. And that structure of that data in the data warehouse is optimized for the analysis that the users are going to want to make of it. If they have to run very long queries, long-running queries, then the information is not going to be as useful to them, or it's just going to be plain frustrating for them to use if they have to wait for the machine to run. So the data that's in the data warehouse needs to already be in a format that they can use that. A data lake, on the other hand, is also a data store, but it hasn't had that high structure applied to it yet. And the reason for this is that it's often difficult for a data engineer to figure out exactly what a user, a data analyst or business user is going to need. And it may take a long time for the data engineer to prepare the data or to construct something that's going to deliver that, or it may put too much of a heavy load on the source data system. So in the case of a data lake is a matter of trying to get the data out of the source systems and into an area where lots of other people can look at it and apply their own expertise to that. So the structure of a data warehouse, it has summary data that can be used so that people can apply their own visualization tools, reporting tools to work with it. Metadata is data about the data. So an explanation about where the data has come from, its quality and its veracity is important to understand, because we need to understand what the data is and what it is good for. And then there may still be some raw data that is used to feed the summary data when we need to drill down to some details. So that needs to be available to the users of that data. So the different data sources, and these come from different places. So the sources can be a database on an application. This might be a MySQL or a PostgreSQL, other types of SQL or NoSQL databases that are supporting a business application. It may be available through an API, an application programming interface, and that may also be from a business application, or it may have already been pre-processed by another party, either within the organization or outside the organization. It may be, and being able to access data through an API can be very helpful in adding and enriching the data that you get from the business application. For data that is based on events or needs to be updated or ingested as soon as it happens, we may have a stream processing platform like Apache Kafka. It may simply be in a storage bucket like Amazon S3. It may be in someone else's data warehouse or data lake or some other file format. And then the structure of that data as it comes in. If it's coming from a REST API, it's probably in a JSON format. If it's coming from a SQL database, then it'll be in a SQL format. It may be log data from a web application, from a system. We may be monitoring a system, and we want to examine all the logs associated with the running of that system. It can be in a flat file format. So there are a number of concerns about these data sources. One of the first ones is who owns the data. We may need to get permission from the owner of that data. There's probably going to be some security or role-based access control around that, and we're going to need to comply with that security and access protocol in order to get hold of the data. We need to be able to deal with the data volume, whether it's large. If it's a very large volume, then we need to consider how much storage we're going to need, and also the access speed of that, because running queries can take a long time on large data sets. The data is not always very clean. Sometimes we need to fix some of the data because it's just there is missing data, or there are some characteristics about it that our users can't use. And then latency and bandwidth refers to how quickly we're going to be able to get the data, how much bandwidth we're going to need in order to access that volume of data. So the data ingestion tools, we can build our own using SQL or Python or other languages. We can use data ingestion tools. And sometimes it makes sense to buy a tool, because they very often have connectors to different types of data sources, and we're able to create our data pipeline quickly. But of course, those things have a cost to them. So for small types of data, or where we need to build a specialist connector anyway, then it may make sense to build our own. we need to be able to transform the data and modify it. And again, we may decide to build that ourselves, or we may use another tool in order to do that. With quite complex pipelines, where we have lots of different data sources coming into being ingested and then transformed and put into a data lake or warehouse, we may struggle to orchestrate all of that ourselves. So there are tools known as a workflow orchestration platform that can help us to manage that. If we've got hundreds of these jobs running every day, then it can make sense to use these. The workflow orchestration platforms work on what's known as a directed acyclic graph. That is, as the diagram shows, tasks are performed from left to right, and they don't go backwards, because if you can mess up your data a lot if one task is using data and then sends data back to the previous task, and can create a loop that might never end. So the directed acyclic graph, or DAG, is the cornerstone of how you build the data pipeline using the workflow orchestration platform. Okay, so we're going to look at the most common patterns that we have here. The most common patterns that you will find are the ETL and the ELT patterns. And these are essentially the same components, but they're executed in a different sequence. So ETL has been around for a lot longer. It's where we extract data from the data sources, we transform it, we make any modifications we need to make to the format of it, and then we load it into the destination system. ELT, I've messed up my slide here, I need to alter it. ELT is where we don't try to transform it before we load it into the destination system. We try to get it there as quickly as possible. And the reason we would do that is that when we give the data to the data analyst to work with them, they probably have a better understanding of the business problem they're trying to solve. And so they may have a better understanding of how the data needs to be transformed by whereas they don't necessarily know how to collect it from all the different source systems. And that's really the area of the data engineer. So when we use the ELT pattern, we let the data engineer do what they're good at, and we let the data analyst do what they're good at, and they don't have to, the data engineer doesn't have to wait for the analyst to do their work before they load it into the destination system. A variation on the ELT is the ETLT subpattern. The small t refers to there may need to be some minor transformation of the data before we move it, before we load it into the destination system. So an example of that may be some pre-processing that we need to do, say for a machine learning pipeline. So machine learning is a little more specialized in that we may still use the ELT pattern, but we may need to do some data processing and cleaning it, and this is why the ETLT pattern subpattern may be more useful. So the model training occurs after the data is ingested and pre-processed, and then it needs to be deployed. Now, one way of deploying it is through through an API so that people can come and access it, and then they have a good understanding of they don't have to worry about the structure of the data so much. They're relying on the people who created, the data scientists who created the machine learning algorithm and model, that the model is correct. They do need to be sure which version of the model that they're using, and so this has to be taken into account in constructing the API. So a couple of methods for the extraction phase. So if you're taking data from a MySQL database, you can use the SQL itself to do an extraction, either the complete database or database table, or incrementally. And this is probably the easiest thing to implement. The challenge, of course, it creates is you're going to take an entire copy of the database. That may be quite time-consuming for a very large data set. And the alternative method of extracting data from MySQL is a bin log replication, and this uses one of the lower level tools to capture recent changes to the database. So an example of extracting using SQL, a full extraction is simply selecting everything that you're looking for from the tables that you are. Whereas you can do this incrementally if you add a condition that you only want, you keep track of when you last updated the destination system, and then you only get the ones that have happened since then. The challenge with this method is that you have to have quite a reliable timestamp for your data. Otherwise, it may get out of sync. And another challenge is that if a row is deleted in the source system, this where clause won't pick that up, and it won't pass that through to the destination. So the bin log for MySQL is an example of what's known as change data capture, and different implementations of SQL databases have different methods of this. For PostgreSQL, it's known as a write-ahead log, but these can be quite tricky. So often people elect to use a framework or a commercial product to help with that. And one example is using Kafka in combination with Debezium in order to connect to the MySQL and put it into the Kafka streaming capability to push that into your data warehouse. Extracting from data from a REST API, well, you need to make a request, and you probably get the result in a JSON array, and then you may need to push that into a flat file or a CSV file in order to make that available to the destination. So these are some of the patterns that you can apply when it gets to streaming data. Is much more complex, and I think next speaker is going to talk a lot more about speaking. But I want to go back to what are the key reasons for constructing your data pipeline, and does it address those key questions? So I hope you've found some value out of that. If you're looking for a good reference for data pipelines, this is one that I found very helpful, Data Pipelines Pocket Reference. and I have the link in there, which I already shared this this deck. And if you want to know more about me and my initiatives, you can connect with me on LinkedIn, my own company, Blue Connector, as well as the community and education activities I'm involved with. Thank you very much.
All right. Thank you, Jon, for your insightful presentation.